Hello dear students, welcome back to NEET World, and we are continuing our discussion on hydrocarbons. So in the last session we have covered up to preparation of alkanes right now. So we have discussed it very clearly, and in this session we will be discussing their chemical properties. Preparation and physical properties were completed in the last class. Now here we will be discussing their chemical properties of hydrocarbons. So look at here. So these are the chemical properties we need to be focused in this chapter. See, first thing here they are saying alkanes substitution reaction. Alkanes undergo substitution reactions. Now we know alkanes are very less reactive right now. So now see here, alkanes are inert to the most reagents under normal condition. Therefore they require some specific conditions. Okay, for example, in presence of some sunlight or suitable frequency, alkanes shows this free radical substitution reaction. So what they will show? Free radical substitution reaction will be exhibited or shown by the alkanes at what condition? Under sunlight or some suitable frequency. Okay, H nu we can indicate. And alkanes will undergo combustion reaction. Like best example is fuels like petrol, diesel are there now. So petrol is a best example for having we can be used as a fuel because of its high heat of combustion. Okay, so it will liberate more amount of heat upon combustion right now. So it will undergo combustion reaction. Okay, and the next alkanes will be also showing some controlled oxidation reactions where we can prepare carbon monoxide. From that we can again forward can prepare methanol and all. Okay, the next isomerization of these alkanes we need to study, and aromatization. So straight chain compounds can be converted into aromatic compounds. Next reaction with steam, and the next pyrolysis. What do we mean by pyrolysis? Breaking of larger molecules into small. Okay, right. But here what I am saying, this reaction will be possible under specific conditions, suitable conditions only, not at the normal conditions. Okay, just remember this statement. Yes. Next. Here free radical substitution reaction. Just see here what I am writing. What is the simplest alkane we know? So that is methane. Simplest hydrocarbon or alkane we know is methane. So this methane undergoes substitution reaction, like it can react with the halogens like chlorine, bromine, like that. Okay, in presence of what? Sunlight. Okay, so now what happens? One of the hydrogen might be replaced by chlorine. So you will get CH3Cl like that. Okay, so this will be the scenario when you are taking excess quantity of methane. So what should be the excess one here? Methane. Okay, but what if we take chlorine as an excess? See, if we take chlorine as excess and methane as a limiting reagent, so all the hydrogens here replaced by chlorine, so that you will get CCl4 as a major product along with some other byproducts. Okay, so if you take Cl2 as excess, so CCl4 will be the major product. Okay, and if you take methane as excess, methyl chloride will be major product. Okay, so these are the two scenarios, and here you can get HCl, and here you will get some byproducts along with the HCl. Okay, along with the CCl4. Okay, remember this thing. Okay, so now what is the scenario here? You are seeing one of the hydrogen atom replaced by chlorine now. So this will be like what mechanism followed? First of all, when chlorine, it's a like symmetrical reagent now. See, chlorine. Therefore the forces on this bond will be same from the both sides. From both ends it will be having same forces. Now whenever we pass sunlight or some suitable frequency, now what happens? This bond will break into two equal halves, like homolytic cleavage takes place like this to generate two chlorine radicals. Okay, these two chlorine radicals are highly reactive. Now we can say chlorine free radical. So that chlorine free radical will attack on this methane. Okay, so now what will we do? That chlorine radical will do? It will abstract a hydrogen from here in the radical manner. Okay, it means this chlorine radical is there now. so this radical will take one of this hydrogen by breaking this bond homolytically. Okay, so this will be paired up, so you are going to get this radical like a methyl radical, like methyl radical will be produced. Okay, so that methyl radical again react with one more chlorine and you may get this kind of methyl chloride. Okay, or some other products also formed. Here I am not giving all complete mechanism. Okay, so in free radical substitution reaction there are 3 steps. What is the first step? So here first step is chain initiation. See what is this chain initiation? See, by breaking of this chlorine molecule we got chlorine radical now. Okay, this chlorine radical will attack here, so that is what chain propagation step we will call. Okay, so after this chain propagation steps, third step will be called as chain termination, where the reaction will be terminated, like ended up. Okay, so these are the 3 steps followed in the free radical substitution reaction mechanisms. Okay, remember this point. Okay, then next. So now more than this, you might expect one question in the exam in this way. See, they will give CH3, CH2, CH3. Like this they will give one alkane. Now they will ask us to do chlorination on this in presence of sunlight, and now they will ask how many types of monochlorinated products are formed from this. Okay, this is very simple now. How many types of monochlorinated products? It means you need to remove one of this hydrogen by this chlorine. Okay, you need to replace this one of the hydrogen by chlorine. So now if I replace this terminal hydrogen by chlorine, what happens, tell me? CH3, CH2, CH2 here, and if I replace this hydrogen by chlorine, you will get a terminal chloride like this. Okay, propyl chloride will be formed. Okay, now even if you replace one of the hydrogen from this terminal methyl group, same kind of product will be formed. It means this terminal methyl and this terminal methyls are same. Okay, so both of them are giving one product now. So let us say this is of A type product formed by replacing hydrogens from this terminal methyl groups. Okay, now what happens if I replace hydrogen from this middle carbon? So if you replace from this middle carbon, that is I am mentioning it as B, and this terminal methyl groups as A. Okay, so now what happens, this hydrogen if we replace, you will get CH3, CH, CH3, and here Cl. Okay, so this is how you will get a B type of product. Okay, you got A type and B type products in this way. Hope the discussion is clear. So now how many types of products you are seeing? A type and B type. So 2 types of products. So now how you are saying these are 2 types of product? By looking at the type of hydrogen, how many types of hydrogens present in the given substrate. Okay, if substrate contain 2 types of hydrogen, you will get 2 types of product. If it contains 1 type only, you will get 1 type of product. If you contain 3-4 types, like that, depends on that the types of products formed will be decided. Okay, this is one thing. And one more thing, if you observe, there is no chiral center generated in the first option. But if you observe second center also, there is no chiral center observed. But here I am going to give you one more question here. Just look at this. Like this I am giving. Okay, so if you chlorinate this, so where it happens, either it happens here inside or this outside. Okay, or if you want to take, you just take this one. Like this I am taking. So how like this? Now what are the possible products? Tell me. See here I am using different colors. See, this is a carbon which we can say primary carbons. These are okay, primary carbons. So primary methyl groups are there. How many are there? 1, 2. Okay, and this is also primary. This is also primary, but this primary, this pink color primary and this carbon is not same, because it is attached to a secondary carbon, and these pink color carbons, primary methyl groups, are attached to the tertiary carbon right now. So it means these 2 are not same. So these 2 will be giving 1 type of product, and this will be giving second type of product, and this will be giving a third type of product, and here you have 1 hydrogen. So this will be giving your 4th type of products. So how many types of products we will be having? 4 types. Okay, but after writing, if it is having any chiral center in the newly formed product, then with respect to 1 chiral center, 2 products will be formed. What I am saying? See, just listen here what I am writing. See, by replacing this hydrogen at this terminal methyl groups, so what we are going to get? See, if I replace hydrogen by chlorine, you will get one type, and then next this is A type, let us say. And if I replace hydrogen from here, this is second type, B type you can say. And if I replace hydrogen from here, this is third type you can say. And if I replace hydrogen from here, you will get fourth type. Like this, how many we got? A, B, C, D type products, 4 products are produced. But just identify how many of them are having now chiral center in them. So just check how many of them are having chiral centers. See here, you have a chiral center. No, here we do not have any chiral center. Okay, see, chiral center means what? Carbon with 4 different groups. See, this carbon is having methyl, this is chlorine fine, this is ethyl, it is also different, but both side methyl now, so this is not a chiral. So it is only one type of product. But if you look at this, how many are there chiral centers? See, this is a chiral center newly generated now, because this side is methyl, this is chlorine, one more is hydrogen, and this side is some secondary propyl group is attached, isopropyl group is attached. So you can say here you can have above the plane chlorine or below the plane chlorine, because replacing above the plane hydrogen will get one type of product, and below the plane hydrogen another type of product. So here possibilities are 2, okay, one is R isomer, one is S isomer. And here if you see, yes, there is no chiral center here also, this is also 1, and here 1, 2, 3, 4. And what about this case? See, what about this case? See, when we add here, you got a chiral center here. So how many are there? Here also 2. So 2 plus 2, 4, 5, 6. So total products are 6 formed in this particular reaction. Okay, right. So guys, tell me any confusions here? Let me show you some questions from these. So just answer me for this. If you chlorinate this, number of monochlorinated products, here questions will be asked in 2 ways. One is number of monochlorinated products they are asking now. So one question they may give like this, only consider only structural isomers. What they will say? Structural isomers. Okay, they may mention like this. Our second question will be like, consider both structural and stereo isomers. They may ask like this. So just try this question, and I am mentioning here question number 1. Are you mention the time slot, I mean in the time stamp in the comment box when you are answering for this particular question in the comment box. I will definitely look into it. Whenever you are watching this video, whether it is live, recorded version you are watching, no worries, you just try to attempt it. I am going to look into it. Okay, right. Next. Okay, so next one is here. In this free radical substitution reaction, we can have iodination, bromination, chlorination, fluorination. But fluorination, the reactivity of fluorines are more, so fluorination is very vigorous reaction that we cannot handle it. Okay, therefore alkanes upon treating with fluorine in presence of sunlight, it is a very vigorous reaction. See, it is explosive and violent, and it is cannot be controlled. Okay, therefore what this method is not preferable to synthesize or prepare fluoroalkyl fluorines, I mean fluoroalkenes. Okay, and when it comes to iodination is very less reaction, and it is a reversible reaction. Okay, it is slow, and it is very slow, and it is reversible reaction, very slow and reversible reaction. Therefore it is carried out in presence of oxidizing agents like HiO3 and HNO3. So what to do? In order to do this iodination, since it is a very slow reaction, reversible reaction, so we can use it in presence of oxidizing agent, okay, like HNO3 and HiO3. Okay, remember this statement. So what is the reactivity order? Fluorination, chlorination, bromination, and least is iodination. And in these 2 cases, chlorination is more reactive than bromination. Okay, so alkyl chloride bromide synthesis can be done in this way because the reactivity is proper when we compare with fluorines and chlorines. Anyways, to prepare alkyl halides we do not prefer this method, but we need to know what type of reaction and what is happening exactly, because in this reaction we will get multiple types of products possible. Okay, so you might be having major product one, but along with that major product there are many minor products. So to separate all these things it will be like very difficult process, you can say. Okay, so that's why we won't prefer this method, but we need to know for preparation of alkyl chlorides from alkane this is one of the reaction possible. Okay, so now between chlorine and bromine which is more reactive? Chlorine is more reactive. No, whenever if you are saying a species is more reactive, it means it will react very vigorously, I mean more fasterly, and for a more reactive species there will be less selectivity. So what do we mean by selectivity? I will tell you, just look at here. See, this table says this is an experimental experimentally determined table. So what this table saying is, see, I am writing this type of compound. Okay, so here you have one hydrogen, but what type of hydrogen it is? Tertiary carbon attached hydrogen, right now. So this is a tertiary hydrogen. And what about these hydrogens? These are secondary carbon containing hydrogen, right now. So what about these hydrogens? These are primary hydrogens, no? So now the primary hydrogens, secondary hydrogen, tertiary hydrogen is there. So now what I am saying, chlorination is more reactive now. Yes, chlorination is more reactive, but it has a less selectivity. So whenever I want to do chlorination to the primary hydrogen, it will be one time reactive. Okay, in same case bromination also one time reactive. But when we are doing chlorination and bromination for secondary hydrogen, it means this kind of hydrogen, so chlorination is 3.8 times reactive and here bromination is 82 times. Okay, when we compare with this it will be 82 times. And what about this tertiary hydrogen? Here it is there now. So this will be for bromination it is more selectively reacts, and for tertiary chlorination it is very less here, 5 times. It means if you want to find what is a major and minor product, for example I am doing bromination. Okay, so what will be the major products formed, they will ask. So how can you identify? Since out of these three, tertiary hydrogen is selectively reacting with for bromination, how many times it is? 1600 times when we compare with the primary. So that it will be giving us this kind of product as major. Okay, so this kind of product as major. Okay, now what are the possible minor products? So we can get primary and we can get secondary also. Those are minor, but this is the major for bromination. Now in the same way, if I ask for chlorination, what you need to do? You need to count number of primary hydrogens. Here how many are there? 3 are there. Here how many are there? 3 are there. So 6 hydrogen atoms are there. Now you can replace one hydrogen from there and you can substitute with chlorine. Okay, and you can replace this tertiary hydrogen also and you may get like this. And one more possible way is here also and here also. Okay, so now what to do? How many hydrogens are there? Multiply that with these numbers. If primary hydrogens are 6, so 6 into 1, so this many times chlorine will react. Secondary hydrogens are 2, so that is 3.8 into 2. So how much we will get? 16, 1, 6, 7, 7.6 times. Okay, and what about chlorination for tertiary? So tertiary hydrogen is 1. Okay, it will be having 5 times here. So 5. So which quantity is greater here? Secondary quantity is greater now. So that will be major. So which will be major here? So secondary hydrogen. It means this will be the major product for chlorination, and for bromination tertiary hydrogen containing compound like that carbon will be more selectively reacts here. Okay, this is how you need to predict major minor products in the given reaction. Okay, right. Next. See, this is not preferred way of producing alkyl halides from alkanes, as it gives multiple products, okay, and resulting in low yield. Okay, product formed will be very less yield as number of products are formed here. Different number of products are formed here. Okay, and combustion reaction. So let us consider a hydrocarbon having formula like CXHY. So combustion, upon complete combustion, it means complete combustion means oxygen will be in excess quantity here. Okay, so now how many carbons are there? X number of carbon atoms. So it will be giving XCO2. Okay, plus here how many hydrogens are there? Y hydrogens are there, but here I am writing H2O. It means how many hydrogen atoms are there? 2 now in one molecule. You can take Y by 2 hydrogen molecules. Okay, and one more thing. Now tell me how many oxygen molecules or atoms required here. So how do we do this? So multiply this here 2x plus this is x by 2 oxygen atoms are there. Oxygen atoms are there. Here this is a molecule now. So molecule contain 2 hydrogen atoms. So this number you take here by divided by 2. Therefore 2x plus y by 2 by 2. Okay, this is nothing but x plus y by 4. Okay, this will be your number of oxygen molecules are required for the combustion of this particular hydrocarbon. Okay, so this is how you need to balance the reaction. Okay, you can expect a question directly from this by giving a simple hydrocarbon. So tell me how many moles of water formed or how many moles of oxygen required, oxygen molecules are required for complete combustion of butane. So C4H10 they will mention and they will ask this is stoichiometric coefficients. What are the stoichiometric coefficients? Okay, this is a very simple question you can expect in EAPCET exam. Okay, like this they may ask. Okay, now controlled oxidation. Controlled oxidation means we will be giving regular supply. It means alkanes and heating in a regulated supply of O2 or air at a high pressure and in presence of suitable catalyst gives a variety of oxidation products. For example, here we can prepare methanol, such kind of reactions are there here. See, methane is there upon treating with oxygen. This is an oxidation process only now. So in presence of copper metal, what is the catalyst used here? Copper metal, and suitable conditions are 523 Kelvin and high pressures are required, 100 atm pressures. So that produces methanol. Okay, what is that? Methanol is produced from methane upon oxidation in presence of copper metal, okay, and at 523 Kelvin and 100 atm pressures. Okay, remember this point. And the next thing here is methane upon treating with oxygen in molybdenum oxide under heating condition produces formaldehyde. What is this? Formaldehyde is produced. Here it is an alcohol, here it is an aldehyde. So you can say methanol, this is methanol. Okay, methanol, methanol or formaldehyde, you can simply call it. Okay, and when we have ethane treating with oxygen, so here I have manganese acetate. What do we have? Manganese acetate under heating condition. So methane, like ethane, now converts into acetic acid. What it is formed? Acetic acid is produced. Okay, so ethane converted into acetic acid in presence of manganese acetate under oxidation process. Okay, right. Next, remember these three reactions are important because these are selectively converting into some products. Specific products are formed when we are using specific catalyst. Okay. Next, oxidation of alkanes. See, alkanes, generally alkanes resist oxidation, but alkanes having 3° hydrogen atom can be oxidized to alcohol by KMnO4. See, if I take a simple butane like this, it does not have any tertiary hydrogen now, there is no tertiary hydrogen. If I supply oxygen or if I want to do any oxidation process here, okay, so generally it will not show any type of oxidized product here, okay, generally, okay. But when we have a tertiary hydrogen, just see what I am writing here. So this is a methyl group, this side also methyl, this side is ethyl, and you have one tertiary carbon. This is what now? This is a tertiary carbon and hydrogen. So if I want to treat this with KMnO4, with what I am treating? With KMnO4. So with KMnO4, what happens? This tertiary hydrogen is like, you can consider like a activated hydrogen, and that will be oxidized by KMnO4 oxidizing agent and gives a tertiary alcohol. So just write here OH, that's it. This is your final product from the given alkane. Okay, with what? With the KMnO4 like oxidizing agents. Okay, remember this. Okay, right. This is very important reaction, and there are multiple times asked in the EAPCET exams. So we have some questions to be solved based on this. I will show you. Okay, and next one is heat of combustion. So amount of heat released during a combustion process. Okay, so now see, heat of combustion is inversely proportional to branching of an alkane. Okay, so branching of an alkane, more the number of branches, lesser will be the heat of combustion. What they are saying? More the number of branches, lesser will be the heat of combustion. Okay, this is a straight chain and it has one branch, it has two branches. Okay, so now what we can say? More the number of branches, lower will be the heat of combustion. So here it's a straight chain having more heat of combustion and little branched and more branched. So this will be the order of heat of combustion. So it depends on what? Branching of alkane. So more the number of branches, lower will be the heat of combustion. Remember this point. Okay, so for example, they will ask a simple question like this and like this. So AB, which is having more heat of combustion. So here it is, both of them are having 5 carbons, but it is a straight chain, 5 carbon, but it's a 4 carbons and 1 methyl group is there. So out of these two, which is straight chain here, A na, so more branches, lower heat of hydrogenation, heat of combustion. So that's it. So it's a straight chain, so it has more heat of combustion than the second. Okay, this is how you need to answer. It is very simple. And the next term, isomerization of N-hexane. So what do we mean by isomerization? Converting one one compound into its isomeric form. What do we mean by isomers? Molecules having same chemical formula, but they might be differing their structure or spatial arrangement. Here particularly isomerization means it is differing their structure. So these are forming the structural isomers. So what are the structural isomers? For example, here N-hexane is there, N-hexane is there. So this N-hexane upon treating with this AlCl3, anhydrous AlCl3 under heating condition, it will be getting a branched isomer. So like isopentane, like this we may get some branched compound like isomeric compounds. So N-alkanes on heating in presence of anhydrous AlCl3 and HCl isomerized to form branched chain alkanes. See, N-alkane converted into branched alkane. Okay, so what is the catalyst used here? Anhydrous AlCl3 under heating condition. Okay, remember this. Okay, straight chain converts into branched chain, okay, in presence of AlCl3. Now look at this, aromatization. So what do we mean by aromatization? Again it is simple. Aromatization means a straight chain hydrocarbon can be converted into a ring form like aromatic compound. For example, N-hexane if we take, N-hexane contain how many carbons? 6 carbons now. So these 6 carbons containing hydrocarbon converts into its aromatic product. So what is the aromatic product having 6 carbons? It is simple benzene now. So we are going to get a N-hexane upon treating with chromic oxide like chromium oxide, chromium trioxide or V2O5 or molybdenum trioxide gives benzene. So any of these oxidizing agent here will be preferred. Okay, so what is the temperature pressure mentioned? 10 to 20 atm. Okay, so this is supported by Al2O3, that is alumina. Okay, so heating gives benzene. So now what if we take N-heptane? So this is N-hexane. Now we are taking 1, 2, 3, 4, 5, 6, 7. N-heptane now. So these upon aromatization using any of these compound Cr2O3 and Al2O3, okay, because this is supported for this oxidizing agent. So what is the temperature used? 773 Kelvin and 10 to 20 atm. So now what happens? 1, 2, 3, 4, 5, 6, 7. So 7 are there. So you will get 6 membered ring first, hexane, and here a methyl group. Here a methyl group. Here a methyl group. Okay. Heptane converts into N-heptane converted into methyl benzene, that is what? Toluene. Okay, this is also one of the very general question we will be seeing in the exam. Okay, conversion. Now I will show you the question based on this, no worries. Okay, see, let me show you some questions first. So look at this. So look at this, what they are asking, tell me. Just now we have seen that. It's an EAP set question now. So tell me what they are asking in the question. What are X and Y respectively in the following reaction sequence? See how many carbons are there in the given substrate. Just count 1, 2, 3, 4, 5, 6, 7. 7 carbons are there. Upon treating with some compound X, compound like some reagent X, so it will be forming some product. So this again treating with bromine under heating condition, it will be giving us Y. So what is X and Y during this process? So it is very simple. So that is heptane now. So what type of product form? It will be undergoing aromatization. See, N-heptane giving aromatic product, that is toluene, like methyl benzene. So now what will be our X here? So X will be chromic oxide or molybdenum trioxide, we have seen 773 Kelvin or 770 around in and around temperature. Okay, and after this, so here we have more specific conditions, this is okay, and then after this bromine under heating conditions. See, so now what happens is, you know, bromine will not attack on this benzene ring in presence of heating, like symmetrical reagent is given now. So from, and this one given with heating condition. Now what happens? Homolytic cleavage of bromine takes place to generate bromine radical. So this bromine radical will attack on this methyl carbon. Okay, so if it is attacking on methyl carbon, one hydrogen is replaced by one bromine radical. Therefore, you will get a methyl, benzyl bromine, bromobenzene. At benzylic position, we will get a bromine here. Okay, so at benzylic position, at this carbon, we will get a bromine here, like this. Okay, so this is what a simple free radical substitution reaction taking place at alkyl group. Remember, whenever alkyl benzene is given, any alkyl benzene is given, so if there is any alpha, any hydrogen on this benzylic position carbon, so this position carbon is called benzylic carbon. So on that, if any hydrogens are present, that will be replaced by halogens if we treat with bromine under heating condition, okay, or chlorine under heating or sunlight. Like this they mention means what to do? Just replace this hydrogen with the halogen atom given here, okay, or they may give NBS. What do we mean by NBS? N-bromosuccinamide. It is a allylic and benzylic brominating agent. So wherever we have this benzylic hydrogens, replace with bromine if they give like NCS or NBS. So NBS means you need to do bromination, NCS means you need to do chlorination, that's it. Okay, remember these points. So what is the suitable answer for this? So here you have benzylic bromination, and this is aromatization. So X and Y will be these things. So option D will be your answer for the question. Next, combustion reactions we already discussed. Next we need to discuss about alkenes. So guys, till now whatever we have discussed from alkenes topic, I hope everything is clear. So guys, if you are preparing seriously for your JEE, NEET or EAPCET exams, just take, if you have watched complete sessions, I hope you will not be having any doubts now, because I covered maximum things that are required. Okay, so now just go through any of your PYQ book, okay, or any of the questions like related to this alkanes chapter. Give a try, definitely you are going to answer if you watch all my sessions. I mean, just this is the third session on hydrocarbon. Okay. So, if you have any doubts, you can post your doubts in our Telegram group so that I can look into it and will answer back to you for those questions also. No worries, just take the help of our class notes and then next solve some questions, and still if you have any doubts, post in our Telegram group, link will be provided in the description box, or you can also just mention in the WhatsApp number provided in the below, in the description box. Okay. Yes. Next thing, here alkenes. So, these alkenes are unsaturated hydrocarbons with carbon-carbon double bond. So, what do we mean by alkenes? Alkenes are unsaturated hydrocarbons. So, generally we know alkanes are saturated, means they have only single sigma bond between carbon-carbon atoms in a given compound. Those are alkanes. Here we are saying unsaturated. So, alkanes are saturated because they have only sigma bonds. These are alkenes, these are unsaturated, those are saturated. So, alkenes contains a sigma bond and a pi bond, okay, whereas alkynes contain one sigma, two pi bonds. Okay, this is a scenario, and remaining valency of carbon is balanced by hydrogen atoms or some other alkyl groups, other carbon atoms, near adjacent carbon atoms like this. Okay, how many required here? How many like this? Any methyl group or something will be attached. Okay. So, now what is a hybridization of alkene carbons? These are sp2. What I am saying? sp2. And what about this? sp3. sp hybridization in alkynes. Okay. And one more thing, alkenes are also called as olefins. What I am saying? Olefins. So, what do we mean by olefins? Olefins are nothing but oily like compounds, like they are oil forming compounds. Okay. Most of the oils, if you consider, you just check any oil you take and search in the Google, you will get them as like unsaturated compounds. Okay. So, those are oily forming compounds, like oils, fats. If you consider, just check how they are, just check their structure, you will get to know those are nothing but our hydrocarbons, and most of them are our alkenes only. And the next, what will be the formula, general formula for alkenes? CnH2n plus 2 is for alkenes and CnH2n is alkenes. What is the simplest alkene possible? See, take alkenes means definitely there should be 2 carbon atoms minimum, between them there should be a sigma and pi bond. It means minimum carbons are 2, between them 2 bonds should be there, 1 sigma and 1 pi. Okay, it should be C2H4. Okay, this will be the formula. Okay, for what? This is for alkenes. This is for what? Alkenes. Okay, remember this statement and all. Okay, next. Okay, so now these alkenes will show geometrical isomerism. So, what do we mean by geometrical isomerism? See, isomers possess same molecular formula, but and same molecular and structural formula, but differ in the arrangement of atoms, groups in the space. So, spatial arrangement of atoms or group of atoms are differ in the space. I mean, spatial arrangement is different. Simply look at here, C double bond C is there. Here I am writing methyl group, here I am writing methyl group, and this side is hydrogen, hydrogen. Okay. So, now with the same molecular formula, what I am doing, just look at this, methyl, hydrogen, hydrogen and methyl. Now, how do they differ? 1 and 2, A and B, how do they differ? See, this side it is same, this side it is same. But if you observe this side, methyl group is top side, okay, same side of this methyl group, but here methyl group is opposite side of the other methyl group right now. So, how do they differ? They have same bond connectivity, here one methyl, one hydrogen, here also one methyl, one hydrogen, here also same scenario will be there, but the arrangement, the spatial arrangement, the spatial orientation of these surrounding atoms are different, surrounding groups are different. See, here how do they differ? This side is same, but this side they are having difference in their spatial arrangement. So, now these two isomers are called geometrical isomers. What I am saying? Geometrical isomers. Okay, geometrical isomers. So like molecular form, like compounds, alkenes, which are differ in the spatial arrangement of group atoms or group of atoms are called geometrical isomers. Okay, particularly if I want to say, if same groups are on same side, see methyl same side now, if same groups are on same side, you should call it as cis isomer. What is that? Cis isomer. If same groups are on opposite side, you should call it as a trans isomer. What I am saying? Trans isomer. So cis, trans isomers are possible in case of alkenes. Okay, and then next, if these alkyl groups are differed, for example, this is what, how these methyl groups are arranged opposite to each other. Now you can say trans. Okay, so this is what, same groups are there, that's why we are saying trans. Now what I am doing is, here I am attaching ethyl, this side is methyl. Now these groups are not same now, so now in this case, when the groups attached here are different, for example, one side hydrogen and this side I am attaching chlorine. Now tell me whether it is cis trans. Yes, we cannot say cis trans in this case because 4 groups attached here are differ. So now here you need to follow some basic rules called CIP rules to indicate its geometrical isomerism. Okay, see how do we use these CIP rules? As per these, on these double bonded carbons, the attached groups are there now, so you need to follow their atomic number. See, this is atomic number 1 and here carbon is there, atomic number 6. This side chlorine is there, this is 17, and this side is methyl is there, this is carbon is 6. So as per atomic numbers, which is more prioritized here, so chlorine greater, here carbon greater. So greater number, like greater priority groups, more priority groups are same side now, same side of these double bond carbons now, you should call it as Z isomer. Okay, if they are opposite side like this, you just see here what I am writing. See chlorine, out of these 2, this is more priority group as per atomic number, out of these 2, this is more priority group. So more priority groups, how they are arranged, they are opposite to each other now. In this case you should say E isomer. If they are same side you should say Z, they are opposite side you should say E. Okay, so this is how we will be giving EZ isomerism or geometrical isomerism for alkenes with 4 different groups around the double bonded carbons. Okay, right. So preparation of alkenes. So we can prepare alkenes from this many ways. So we can use alkenes upon partial reduction. What I am doing? Partial reduction. Some metal will be used here. Partial reduction gives alkenes. Okay, and the next, from alkyl halides by elimination reaction we will get this alkenes. Okay, from vicinal dihalides also we can get, and from alcohols also by elimination we will get this alkenes. So these are the possible ways, some important possible ways to prepare alkene. Okay, right. Next thing here, if you observe, I will tell you preparation methods again. Preparation methods of alkenes. Here if you observe, we have different types of alkenes I have mentioned here. See, this is a double bonded carbons having hydrogen atoms around them, only hydrogen atoms. Here if you observe, one methyl group is there, one alkyl group is there. Here you have 2 alkyl groups on the double bonded carbons. Here you have 2 alkyl groups opposite to each other. Here you have 2 alkyl groups and same carbon. Then next here you have 3 alkyl groups. Like that, if you observe, more the number of alkyl groups, more is the stability of the double bonded alkene, like that particular alkene. Okay, so the double bonded hydrocarbon. Okay, so tetra substituted, more substituted alkene is more stable. So now what will be the scenario here? 1, 2, next this tetra substituted is more stable, then tri substituted, then next di substituted, then mono substituted, and then next unsubstituted. Okay, now they will give this kind of example in the this kind of question in the exam. Like this. out of this AB, which is more stable alkene, they will ask. How can you answer? How can you answer? Tell me. It is easy. See, to the double bonded carbons, here you have the adjacent carbon, that is called alpha carbon. Hydrogens present on these alpha carbons are called alpha hydrogens. So more the number of alpha hydrogens, more is the stability of this double bonded carbon. Okay, so because this will stabilize these double bonded carbons by hyperconjugation. How do they stabilize? By hyperconjugation. So how many hyperconjugations are possible here? So 3 alpha hydrogen, 3 hyperconjugation. Here 3 hyperconjugation with respect to this methyl group. Like that, there are 12 alpha hydrogens, so 12 hyperconjugations are possible in this case. But here if you see, only this methyl group and 2 methyl groups are there. So 6 alpha hydrogens, it means 6 hyperconjugations are possible. So out of this A and B, which is more stabilized? A is more stabilized. Why A is more stabilized? Because more the number of alpha hydrogens, more will be the hyperconjugation and greater will be the stability. Okay, so A is more stable than B. Okay, so this is how you need to answer. Again, they will give cis isomer and trans isomer. Which is more stable? Always remember, in general, trans isomers are more stable than cis isomer. What I am saying? Trans isomers are more stable than cis isomer. Okay, the next preparation methods we are discussing now. So the first preparation is from alkynes. What is that? From alkynes. How do we prepare from alkynes? It is simple. So just take your alkyne and do a partial reduction. Partial reduction means there are triple bonded now, triple bonds and 3 bonds now. So 2 pi bonds and 1 sigma bond is there. So upon adding this H2, what happens? If I add only 1 mole of H2 hydrogen molecule, one hydrogen goes to one carbon, this carbon, and other one here. So like that you will get an alkene like this. So what is the scenario here we are seeing? Out of 3 pi bonds, 3 bonds between the carbon atoms, 1 bond is removed and replaced by 2 hydrogen atoms, 1 hydrogen on each carbon like this. Okay. Now what is the catalyst used here? It is called Lindlar's catalyst. What is that? It is called as Lindlar's catalyst. So what is this Lindlar's catalyst? H2 PD BaSO4 or CaCO3 in the presence of quinoline. So quinoline, what is the use of quinoline here? It will stop the reduction process once after forming alkene. If we are not using this quinoline, or some sulfur containing compound we will be using. If not quinoline, we can use some other sulfur containing compounds like BaSO4 and all. So that will stop the reaction after forming this alkene. If we are not using this, it will be giving us alkane. What it will be giving? Alkane will be formed. But what we are doing, we need to prepare alkenes only. So we must use compound like catalytic poisons like quinolines to stop the reaction after forming alkene. Okay, remember this. So what is the Lindlar's catalyst? H2PD CaCO3 presence of quinoline. Okay, and you know one more. See what type of alkene it is formed? The same alkyl group, same side now. See alkyl groups are on same side, or hydrogens are on same side. If they are on same side, you can say this is cis isomer. What is this? It is a cis isomer. Okay, so you can expect a trans compound also. You can expect a trans compound from alkyne. So for this purpose, you need to use. For this purpose, we need to use sodium or lithium in liquid ammonia. What we need to use? Sodium or lithium in liquid ammonia. So now it will produces high electrons that will be taken one of this carbon, and triple bond converts into double bond by shifting double bond to the one carbon and radical onto the other carbon, and liquid ammonia releases hydrogen atom. That hydrogen will be attached added to the one carbon, and the next followed by one more over the other carbon. Like that you will be converting a given alkyne into alkene. So what type of alkene it is formed? 2 hydrogens opposite side now, you can say it is a trans alkene. Okay, so but trans alkenes are formed in presence of what? Liquid sodium or lithium in presence of liquid ammonia from an alkyne. From where? from alkyne alkene is formed, okay, with what? Sodium or lithium in liquid ammonia. Okay, this process is what? This process is called a bridge reduction. Remember this is a bridge reduction. The product formed will be trans-alkene from an alkyne. If you use a Lindlar's catalyst, that gives a cis-alkene. One of the very most commonly asked question in your EAPCET, NEET or JEE exams from alkenes chapter. Next. Okay. So next, one more thing I wanted to mention here. So if I do a bridge reduction on aromatic ring, on what? Aromatic ring having electron releasing groups like methyl group or some electron releasing group. So bridge reduction product will be Na liquid ammonia. Okay, like this if we take, what happens it is giving a product of this kind. This kind of product will be formed. Okay. So now if it contains electron withdrawing group it contains. So what happens here in this bridge reduction? It will be producing this kind of product. If releasing groups are there, this type of product. Withdrawing groups are there, this type of product is formed in this bridge reduction of aromatic compounds. Okay, right. Next, from alkyl halides. So we'll do this elimination reactions. Okay, and before going to that, just tell me answer for one question I just wanted to ask you. So look at this EAPCET question, tell me what happens. Isopentane they have taken. So isopentane upon treating with KMnO4 you will get X. X upon dehydration you will get Y. So what is your X and Y in the reaction? Okay. So now simply you can answer isopentane. What do we mean by isopentane? You just write these structures, you can just look at the structures you have like this right now. So now this isopentane upon treating with KMnO4, we know alkanes does not react with KMnO4, except alkane, that alkane which contains tertiary hydrogen, remaining other alkanes won't react. Generally they won't get oxidized with oxidizing agents like KMnO4 and such things. But if that alkane contain tertiary hydrogen atom, that will be oxidized by KMnO4 to respect to alcohol. What I am saying? To respect to alcohol. So H converts into OH. So this will be a product X. So this product X on dehydration, what happens? This product X on dehydration gives a Y. So what it will be giving? Y as a major product. So what is this major product Y? Okay. So dehydration means you need to remove this OH group by adding some acid like HCl or H2SO4 like that. So now what happens? This H plus taken by OH group and goes out as a water. Now when it is going out as water, the bonded electrons also taken by OH group only. So you are going to generate a positive charge on this tertiary carbon. So now to that, these are alpha position now. So this is alpha hydrogen. So this will be removed and gives a double bond between them, and you will get a double bond here like this. Okay, so this is your Y. Okay, yes, you got your X and you got your Y. So your X will be like this, I mean in this question. So X, option X will be here and Y will be here. So this is your answer. A is your answer. Okay, hope the discussion is clear. Okay, ozonolysis, all these things we will be discussing in the next class. Just tell me, based on our discussion on hydrocarbons, answer me this question from NEET exam, and also can you answer me this question from today's discussion only? From today's discussion you can easily answer this. And from today's discussion, just now we discussed conversion of alkyne to alkene. What what is the reagent used out of these 4 options? Tell me your answers in the comment box for these questions, whatever I am showing here, and remaining things will be discussed in the next session. Okay, so stay connected with our NEET World channel, and if you have any doubts, write in the chat box. We will discuss them in the next upcoming sessions. Thank you.